We are continuing our discussion of function analysis with relative or local extrema. We talked about what those mean visually, but now we're going to do it in a more formal way, being given equations, being able to find these in a variety of situations. All right, so again, to reiterate, visually it is easy to see where relative extrema are when we view a graph of a function, but if we did not have the graph in front of us, how can we tell where these relative extrema are? If we're given an equation, what do we do to figure this out? So let's ask ourselves. Well, first of all, this is the definition of a relative extrema, a relative maximum point. A relative maximum point is a point where the function changes from increasing to decreasing. So the relative max is a point where the function changes. Here we're increasing, we reach this point, and then we begin to decrease. So this would be a relative maximum point. Okay? Keep in mind that a relative maximum point is a point. It's not just the x value, it is the point. Similarly, a relative minimum point is a point where the function changes from decreasing to increasing. So this would be a relative minimum point. This would also be a relative minimum point. We're going from decreasing to increasing, and the point does exist. So that makes it a relative minimum. Okay, let's look at the point A, f of A. What is f prime of A right here? What is f prime right here? Well, f prime is the slope of the tangent line. The tangent line is horizontal, so what is its slope? Well, it is 0. The sign of f prime changes from what to what at x equals a. So on the left of a, the derivative is positive. From the right of a, the derivative is negative. So we are going from positive to negative. Oops. And that will be true for every relative maximum. Look at the point B, f of B. What is f prime of B? Well, here f prime of B is 0. The sign of f prime changes from what to what at x equals b? Well, here the slope is negative, here the slope is positive, so we change from negative to positive. It makes sense when we're looking at that graph. Totally makes sense. And it's always true. Okay? We said previously that a corner or cusp can be a relative extremum. In this above graph, this corner is a relative minimum because for two reasons. We're going from decreasing to increasing, and because the slope on the left is negative, the slope on the right is positive, and this point does exist. The point does exist. So does the sign change from negative to positive? Yes, it sure does. All right, this process is what we call the first derivative test. Let C be a critical number of f that is continuous. This makes it sound like the critical number is continuous. F is continuous on this open interval containing C. Okay? If f is differentiable on the interval, except possibly at C itself, because we could have a cusp there, okay, then f can be classified as follows. If f prime changes from negative to positive, so negative to positive at x equals c, then f has a relative minimum at that point. If f prime changes from positive to negative at x equals c, then f has a relative maximum at that point. If f prime is negative on both sides of c, or positive on both sides of c, then f has neither a relative min nor a relative max at x equals at that point. Makes sense. All right. Let's look at some examples. All right. Find all relative extrema points. They're points, so we're going to have to find points of this function and designate each as a relative maximum or a relative minimum, and we're going to justify our answers. Okay? So first of all, we're going to, so relative extrema, when I see that, I think I know I need to find the derivative. I'm finding the critical numbers. So I want to find where f prime is 0 or undefined. Okay? And then I'm going to see where f prime changes from negative to positive or positive to negative. Okay? So, f prime. F prime here is 4x cubed minus 32. We're going to set that equal to 0 and solve it for x. So 4x cubed is 32, x cubed is 8, and x is 1. There's only one critical value. There's only one spot where the derivative is 0. Nothing makes this undefined, correct? So there's no cusps on this, and we knew that. This is a polynomial, and they are smooth curves. There's no cusps on any polynomial. So there's only one spot where the slope is 0. So this has to be the location of either a relative max or a relative min. To find out which one, we're going to do a sign chart. Again, anytime we're trying to figure out when something is, that should be f prime, when something is positive or negative, you sign chart it. So that goes on our sign chart. And we are sign charting the derivative. Okay? So I like to put in a large number. So if I put in a large number, a number bigger than 1, like 10, if I put 10 in for x, is the derivative positive or negative? Definitely positive. On the other side, since this 1 came from an odd powered factor, this is going to be negative. Okay? So, on the left of 1, the function is decreasing. On the right of 1, the function is increasing. So we must have a relative minimum value right when x is 1. So I know this is a relative min. Again, we were asked to find a point, so I need to find the y value there. F at 1 is what? F at 1 is 1 to the 4th minus 32 plus 4. That's negative 32 plus 5, so negative 27, right? Doing the math, doing the adding. Okay, so I can say that F has a relative, we're going to abbreviate relative with REL, period, a relative minimum, and we're going to abbreviate minimum with MIN, so relative minimum at 1, negative 27, since f prime changes from negative to positive, and I just use the term there, the word there, since f prime changes from negative to positive there, at that point. Okay? Number 2, find all values of x, if any, at which this function has a local maximum or local minimum on the interval 0 to 2 pi. classify each as the location of a local max or local min, and we are going to justify our answer again. Okay, local max min, I'm looking for where f prime changes from positive to negative or negative to positive. So again, find your critical numbers, sign chart f prime, or in this case, y prime. Okay? So y prime is equal to 1 plus 2 cosine of x. No value of x makes this undefined. If we did have a value, we would add it to our sign chart, but nothing does. Set this equal to 0. All right, I'm going to subtract 1 on both sides, divide both sides by 2, and we have cosine of x is negative 1/2. What angles between 0 and 2 pi make cosine negative 1/2? Well, it'll be a pi over 3 angle, but it'll be in quadrants 2 or 3. So x will be 2 pi over 3 or 4 pi over 3. That's quadrants 2 and 3 where cosine is negative, and again it's pi over 3 since cosine of pi over 3 is 1/2. Okay, 2 pi over 3, 4 pi over 3. All right, those two go on our number line between 0 and 2 pi. All right. I think I'm going to pick a value here, and I think I'm going to pick pi over 2, because pi over 2 is between 0 and 2 pi. I know it is. It's right there. Pi over 2. If I put pi over 2 in for x, cosine of pi over 2 is 0, so I have 1 plus 0. That's positive. So right here we're positive. Now we should know enough about sine and cosine to know that they absolutely will alternate signs as they go across and as they go past any 0. So the next interval will be negative, the next interval will be positive, and if you take your time finding one of these intervals, you can use what you and get it accurate. You can use what you found to get the remaining intervals. So that means that in between 0 and 2 pi over 3, this function, and by the way, we were using y prime there, this function, y, will be increasing, then it will be decreasing, and then increasing again. Okay? So, if we want to know the location of a local max or local min, this 2 pi over 3 will be a relative or local max because we went from increasing to decreasing, and 4 pi over 3 will be a relative min since we went from decreasing to increasing. Y prime went from negative to positive. So I'm going to answer my question here. Y has a local max. Did they want the points or did they want the x values? Just x values. So I'm going to say y has a local max when x equals 2 pi over 3. Since y prime changes from, I'm going to write positive to negative, and an abbreviation for that is a little plus sign. Positive to negative, there. Y has a local min when x is 4 pi over 3. Since y prime changes from negative to positive, there. That's my justification. Justification for that. Okay? All right, one more here. Which of the following is true if f is equal to this function on, again, the interval from 0 to 2 pi? And it's all the choices deal with how many relative maxes, relative minimums there are. Okay, so I know I need to find f prime, and I need to see where it changes signs, and does it change from negative to positive, positive to negative, how many times, all of that, right? So I want f prime to change signs here. So first let's find f prime. I see a quotient. I could change that to a product, moving cosine to the top and making it secant, but I think I'm just going to leave it on the bottom and use the quotient rule. So f prime is equal to, I start on top, take the derivative. The derivative of e to the x is e to the x. Multiply by the bottom left alone. Minus is part of the quotient rule. Now I'm taking the derivative of the bottom, negative sine x, multiply by the top left alone, and I'm going to divide by the bottom squared. Okay? Well, this time we do have a denominator. That's going to affect our sign chart. So let's make note of that. Okay, what values of x make cosine 0? Well, cosine is 0 when x is pi over 2 and 3 pi over 2, all the pi over 2's. But pi over 2 and 3 pi over 2 in the interval that we're looking at. So those two are going to have to go on our sign chart. They're critical numbers. Now I just look at the numerator and set it equal to 0. And as I do that, I see that e to the x is in common, so I am going to factor e to the x out. Negative times a negative is a positive. And I'm setting that equal to 0. Okay. E to the x is never 0. Always positive. Okay. Cosine x plus sine x, we need to set that equal to 0 and find the values of x that make that true. So cosine x plus sine x is 0. Cosine x is equal to negative sine x. What value of x makes sine and cosine opposite signs? Well, it'll be the pi over 4 angle in quadrant 2 and in quadrant 4. So that will be 3 pi over 4 and 7 pi over 4. So I have several values that need to go on our sign chart. So I'm going to put our sign chart, I think I'm going to put our sign chart right here where it's nice and I have a lot of space here. So I'm starting at 0. And what's my next lowest value here? Well, my next lowest, 3 pi over 4 is greater than pi over 2. So I'm going to put pi over 2 on my sign chart. Then 3 pi over 4 needs to go on. Then 3 pi over 2 needs to go on. Then the 7 pi over 4. And then lastly my 2 pi. Okay? We're going to pick one value and do it well because we're going to be using it. Okay, I think I'm going to pick a value right here, like pi over 4. I'm going to pick pi over 4. I'm going to get that sign right there. Pi over 4 is in that interval, right? Okay, I'm going up here, you guys. Okay, I could go here and then pull down that denominator, which would be fine too. E to the x is always positive. Always positive. Cosine of pi over 4 is positive. A negative times a negative is a positive, and sine of pi over 4 is positive. All positive there. Cosine of x squared is also positive. So this interval right here is positive. Okay? Now, I said that I was going to, I think what I'm going to do is I'm going to copy this factor down. And put it over that cosine of x squared. I want you to see that this piece is always positive. This piece is always positive. The pi over 2, oops, hang on just a second. I just timed out. Are we still going? Yes, we're still going. My computer went dark. Okay. Alrighty. So the pi over 2 and the 3 pi over 2 came from this piece that was being squared. So around the pi over 2, we will not change signs. We will stay positive because, again, it came from an even powered factor. Okay? But around the 3 pi over 4, that came from the sine and cosine. That will change signs. Around the 3 pi over 2, we will not change signs. But around the 7 pi over 4, we will change signs. So that's what I meant about use, and you could keep on going and plugging things in and evaluating. It just eats up your time if you do that. Find one interval well, and then use your knowledge of functions to complete your sign chart. That's my best advice to you. We were, by the way, using f prime on our sign chart. That's where we got our zeros from. That's what we're trying to find, etc. Okay, so let's see where our relative min and maxes are. So let's see. This is neither, because we did not change signs. This is a relative max, because we changed from positive to negative. There's no sign change here, so it's a neither. There is a sign change here, and we went from negative to positive, so that is a relative min. One of each. One of each. Okay? Just to reiterate, the function is increasing here, and then it continues to increase here. It's decreasing here and continues to decrease here, and then it increases. Okay? All right. And that is relative extrema.